start recording this one too. Here we go. All right, so let's go ahead and I'm going to give you the name iron 3 chloride. Okay. And can somebody remind us why I have a Roman numeral in the middle of this name? I didn't.
But why? Because there's two versions of iron, one with two cations and one with three of it.
Okay, good. There's two versions of iron ions. There's one with a +2 charge and one with a +3 charge. Right? Iron 3 is which one? Well, the one with the +3 charge. It's that easy, guys. Whatever this number is, that's the charge on it. So, in order for me to write this formula, I need to know what my two ions are, right? The first one, iron 3, I look up the formula, the symbol for iron on the periodic table is Fe. I also look on the periodic table and find that it's a transition metal, so I have no idea what charge it is based on what column is. It's not one of those columns that has a nice little rule. But it gives me the charge right here. So in a lot of ways, it's easier. I'm being given the charge right here. I'm sorry if I'm overdoing this whole idea, but some people make this oh my God, it's so complicated. No, whatever this number is, that's how many positive charges your ion has. So iron 3 is right there. Chloride is on the periodic table in one of those columns that has a rule to it. Chloride is the chlorine ion, and it's in column 17. So all the column 17 elements get a -1 charge, right? So iron 3 chloride is a compound that has iron 3 in it and chloride ion in it. In order to make the formula, once again, we do the same thing we've been doing since the other day. Let's make this a neutral compound. 3 positives, 1 negative. We need more negatives, right? We're going to have to add 3 negatives. We're going to have to have 3 chlorides. 3 times -1 is -3. So therefore, now we'll have 3 positives and 3 negatives if we bring in 3 chlorines. Or if you want, you can do the shortcut like we did the other day, right? The 3 in the charge for iron becomes the subscript for chlorine. The 1 in the charge for chlorine becomes the subscript for iron. So our formula for iron 3 chloride is going to be FeCl3. Okay? That's all there is to it. Like I said, I think it's even easier than the other ones because you don't have to look up the charge on iron. Let's do another one. Tin 2 oxide. What's the formula for tin 2 oxide? Okay. Well, if we find tin is atomic number 50 on the periodic table. Its symbol is Sn. What's the charge on tin 2? +2, yeah. And remember, it's always +2 because it's metal. Yeah, so it's 2 +2. So that's the charge on tin. Oxide is which element? Oxygen, right? Okay, so it's oxygen's number 8 on the periodic table. It's in column 16, so all the column 16 elements get a -2 charge. So since tin has a +2 charge, oxygen has a -2 charge, are they balanced? Yes, they are, right? So we just need 1 tin ion and 1 tin 2 oxide ion specifically, and 1 oxide ion. And that will give us a neutral formula. So the formula for tin 2 oxide is SNO. SNO. Actually, we would have called it SNO. SNO. Now, some people get confused by that because they go, it's tin 2 oxide, but there's no 2's in there. How can that be? Well, remember that the 2 refers to the charge on tin. But because oxygen also had 2 as part of its charge, it was -2. We only needed 1 tin and 1 oxygen. The subscripts tell you how many of each we needed to make it neutral, but it doesn't have to say that there was a 2. But we know that this was tin 2. Okay. And you might see that here more. If I have you give me the formula for tin 2 chloride. All right, so tin 2 oxide is SNO. What's tin 2 chloride? Well, just like tin 2 oxide, tin 2 chloride has a tin with a plus 2 charge. And chloride, or chlorine, just like we saw up here, is a negative 1. Or once again, we could go to the periodic table. Chlorine's in column 17. The chlorine has a negative 1 charge. And if we do our shortcut, the 2 on the charge for tin is the subscript for chlorine. The 1 in the charge for chlorine is the subscript for tin. And we end up with SnCl2. Okay. And some people get confused there because they go, wait, if this is tin 2 chloride, why isn't the 2 after tin? Isn't it tin 2? Okay. Yes, it is. It is tin 2. We needed 2 chlorides to make up for the 2 positive charges on tin. Chloride had 1 negative charge. The tin had 2 positive charge. So we needed 2 of these guys to balance out the charges. That's why the 2 goes with the chlorine, not with the tin. So remember, these subscripts are affected by ions' charges, but they are not the same as the charges. A lot of times you'll see that the charge on one will actually end up as a subscript on the other when we do that. Okay. You can even do these. We can use these polyatomic ions with sorry. We can use these transition metal ions with polyatomic ions. Let's try tin 4 nitrate. Okay. What's the formula for tin 4 nitrate? What's the charge on tin 4? 4, right? So Sn plus 4 charge. And nitrate, oh, there's one of those that ends in 8. So we have to look up nitrate. Well, we just did a little while ago, but if we don't remember that, if we're coming off fresh, doing our assignment, nitrate is NO3. And NO3 has 1 negative charge on there. So tin 4 has 4 positive charges. Nitrate has 1 negative charge. How many nitrates do we need to balance out the charges? So there'll be equal number of pluses and minuses.
One.
So if we have 1 nitrate, then we'll have just 1 negative.
12.
12. Then we'll have 12 negatives.
Oh.
We have four positive charges on tin. 4. So the tin 4 has 4 positives. The nitrate has 1 negative. So we just need 4 of those. All right, so we'll multiply this by 4. So our formula for this one is going to be 1 tin ion and 4 nitrates. But remember, nitrate is a polyatomic ion, so we're going to write it as Sn and then put parentheses NO3 4 times. Okay? All right, so those are our formulas for those guys. Any questions on any of these? The best thing to do is to practice them. I get a lot of, it looks so easy when you do it, but then when I try to do it, I get all befuddled and stuff. Oh yeah, you got to practice it. Then you look at the key and you go, oh, okay, I got that one right. I didn't get this one right. How could I have gotten this one right? All right, so this is giving you a name and then and you come up with the formula. I honestly think this one's probably easier than the worksheet I gave you the other day because I'm giving you on the cation. Right? The last ones we're going to do are, what if I give you the formula, can you give me the name? And I think there's a little bit of trickiness in this one. So let's go ahead and do this one. Right? These are the last ones. So let's say I get, oops, no, sorry, doing the wrong thing here. Try it here. Let's say I give you this formula. How would you name this one? Well, this one seems relatively easy. Right? There's just two elements in here. There's an iron and there's a bromine. So we're going to break this up into, here are our two ions. Right? And obviously there's an iron we start off with. And then we end up with bromine, but bromine ends in actually bromide. We change the ending of the anion to end in IDE. But there's something missing. If you just told me that it was iron bromide, there wouldn't be enough information. Anybody know why?
Because iron has two versions of it.
Yeah, there's two versions of iron. Right? There's two versions of the majority of polyatomic. Of transition metals. So we got to say which one is it. Okay. So is FeBr2, is that iron 2 or is it iron 3? Well, the way you can figure this out is you're going to do a little bit of like semi-algebra. The whole thing's neutral, right? And we know that bromides, each bromide is a -1. And we know there's two of them. So therefore, there's going to be a total of 2 negative charges excuse me, in this formula. But there's only one iron. And there has to be a total of 2 positive charges in this formula. That means that both of those positive charges have to go on the iron. So this is going to be iron 2. Right? We calculate it out. So we're going to call this one iron 2 bromide. Iron bromide is not enough because there's iron 2 bromide and there's iron 3 bromide. FeCl3 would be iron 3 bromide. This one would be this one, so this one is this one. Okay, so the little rule here is whenever you see that the transition metal is your cation, right? When your formula starts with a transition metal, you're going to have to put a Roman numeral in there. And if you look at the worksheet I give you, right, all these guys have a Roman numeral in them because they're all starting with a transition metal. As opposed to the main group metals, which are in columns 1, 2, and 13. You never have to tell me that you have calcium 2. Calcium's always calcium 2. There is no other calcium other than calcium 2. You don't have to tell me that it's potassium 1 because it's always potassium 1. You just say calcium or potassium. But on iron, you have to tell me whether it's iron 2 or iron 3. On copper, you have to tell me whether it's copper 1 or copper 2. Okay? Actually, let's do one here. What about this one? CuS. How would you name that one? Once again, it's made up of 2 elements, copper and sulfur. The sulfur becomes sulfide, right, because it's the anion. The copper, which copper is it? It's a transition metal. Copper's in column 11 there in the transition metal, so we got to figure out what the charge is on it. We know that sulfur, there's only one sulfur here and has a -2 charge. So therefore, what does the charge have to be on copper for the whole thing to be neutral? Good, +2. Right? If this one's -2, there's one sulfur and there's one copper, it has to be +2. So we're going to call this one copper 2. Copper 2 sulfide. Okay, just like that. Now, let's try one more. PbO2. Now Pb, lead, Pb is lead. And lead is not technically in the transition metals, but all those metals, the transition metals kind of spill over into columns 13, 14, 15, below the metal, non-metal line. So we can consider it a transition metal. Tin, lead, all those. So this is just between lead and oxygen. Once again, what's going to be the charge on the lead? Well, we have 2 oxygens here. Each oxygen is a -2. So there's going to be, in this formula, there's a total of 4 negatives. That must mean that there's got to be a total of 4 positives. all four of those positives go on the one lead. So this lead has to be lead 4. And so you're going to go ahead and write it as lead 4. Remember that in Roman numerals 4 is IV, oxide. And there's your answer. Okay? So when you're going ahead and answering the bottom ones over here, don't forget that for number 9 through 16, they all have to have a Roman numeral, because their first element is a transition metal. Okay? All right, I'm going to stop there. You guys can go ahead and work on this. Did I tell you guys that